Hi, Miss Knight. For this video, we're going to be going over chain rule and showing how chain rule is the most important concept in all of calculus AB. And for my beliefs, for calculus AB, chain rule is the most important, as many of its basic topics, such as E with exponents, natural log, and the derivative of natural log, along with taking derivatives and finding the slope or not average rate of change, but slope of many different functions, and also a major topic in calculus AB, which is limits. The main portion of that on how to solve them if it goes 0 over 0 or indifferentiable would be L'Hopital, which is right here. And so for this one, for chain rule, you would get some equation like 2x or 2x x squared plus 6, and then you would get x minus 9 squared. So say these go to 0, 0, both of these, if you plug in 3, they would go to 0, 0. So what you do is you would take the derivative of the top and the derivative of the bottom. And for chain rule, for the bottom, you need to take the derivative of the exponent and put it into the front. So 2, and then the same, keep the middle, x minus 9. And then you would again multiply that by the inside, which for this one it would only be 1, because the derivative of negative 9 is irrelevant, that disappears. And then for the top, you would need to take the derivative of the outside first, which is 2x, which would be 2 x squared minus 9. And then you would need to take the derivative of x squared minus 9, which would be, and you would multiply that, and it would be x squared, or 2x, it would be 2x, and then you would get, if you redo it down here, it goes, simplifying both top and bottom, 4 x squared minus 9 over 2x minus 9. And if you were to, again, plug it in, you would get negative 12 over 0. And so the answer to this limit would be 0. And losing L'Hopital and chain rule, you're able to find that, which is one of the most important things. L'Hopital is used in almost everything through Calc AB. Another way you can use this is through trig functions, which would be cosine, sine, and tangent, and then also cosecant, secant, and cotangent. My example right here is cosine pi x, and then to take the derivative of this, you would need chain rule, because there is something multiplying the x on the inside. And so first you would take the derivative of the outside, which would be negative sine, keep the inside, and then you would multiply this by the derivative of what's in the inside, which would be pi. So this allows you to completely take the derivative of multiple, say there's different layers around parentheses, and then you take the derivative of cosine, and you're also able to take the derivative of the inside, pi times x. So you get negative pi sine x. Negative pi sine pi x. And that would be the derivative of cosine pi x. That's another way you'd be able to use chain rule. A few other ways you'd be able to use chain rule would be through natural log, which if you're taking the derivative of natural log, first you need to do 1 over what's in the inside. So 1 over 2x, multiply by what's in the derivative of what's in the inside, which would be multiplied by 2. So you get 2 over 2x, or 1 over x. and that's how you would take the derivative of natural log. Something else you need to take the natural log of is e to the power of x. So e to the power of x works as the derivative of this is ex squared times 2x. Because first, if you're taking the derivative of this, you get e automatically, and then you would need to take the top of this down and then take the derivative of that, so you would get 2x ex squared as the derivative of this. And then another way you would be able to show chain rule is through tables with multiple functions. So for this one, you have f gx. So gx is inside of fx. And then x equals 1. And then you would need to take the derivative of that. So you would go f derivative gx times g derivative x. And this shows how you would be able to get the derivative of everything instead of just derivative of the outside. So for this one, you will need to go, so if you plug in 1 into gx, that equals 3. So f derivative 3 times g derivative of 1. And then if you do this, you're going to get the answer of 6 times 1, or 6. And this is how you would be able to use tables, and then this would also be able to relate to a graph of these functions. And that's just another way you can use chain rule for Calc AB. And this just provides insight onto how massive the length or variety of problems that you are going to need to be able to use chain rule on for Calc AB, showing how it is the most important function for, or concept in Calc AB. Thank you.